So what we have here today is a thyristor drive. It's a DC drive. So what it does is it takes 3-phase in and converts it to DC out. So on the top here, you got your 3 phases coming in over there. There's the earth. This is a 380 volt 50 hertz supply. And what goes out, a DC. And that goes to our test motor, which is down here. It's that motor over there. This over here is an induction motor. So we had this in for a repair. The control card over here had a problem. So I've replaced it. I'm now doing testing. So on this DC drive over here, there's a pin that you can connect to with your scope, and you can have a look at the pulses from the current transformers coming back. So over here I've got it connected to my confuser. You can see the activity over there on the comms cable. It's USB to 485. And I've got the PC software flashed up over here, CT Soft. Now what I'm going to do is over here, the run bit, I'm going to turn that on. It's going to get a bit noisy. Now what it's doing is it's running forwards and backwards. And over here on the scope, you can see all the pulses are present as it runs forwards and backwards. There on the top line, you can see a longer capture. The scope is set for 50 millivolts per division, and the time base is 4 milliseconds. So if I increase that to 2 milliseconds, you can see there's a pulse every 3.3 milliseconds. So we know that the drive is firing on all cylinders, and there you can see it's running forwards and backwards at 200 RPM. What I've done in the software is I have over here in menu 1 set it up to run 200 minus 200, 200 minus 200 and so on, and it's in preset speeds, and I've told it to just cycle through that and change the speed selection every 2 seconds over here as the time in seconds. So that's what it's busy doing. So if I look at the pulley here, you can see that it's running forwards and backwards. And the other thing we do is we go to the current feedback and we have a look at these values over here, the current being shown. And I'll take my tongue tester, zero it, go on here, and that confirms what I'm reading. That's a field, that's the armature. This is a 180 volt field and 180 volt armature motor. So that's the test that I've got going over here. Let's stop the motor, like so. Now if I go offline with our PC software, I could also open up a scope. It's called CT-scope. So let's look for an old scope trace. What do we got? CT-scope. Why don't we configure a new scope? So what we need to do first of all is set it up for RTU. Now the node address is 1. And let's have a look over here at the output RPM. That will be 1 channel. This is 8 channel scope. Let's add another one. Let's menu 5 voltage. Let's add another one over here. Now why don't we look at the current, like so. So the scope is running. Time base. Over there, let's slow things down a bit. So if you look at the channels, we can see we've got motor RPM, output voltage, and current magnitude. The green line is an analog value, that's why we're seeing some values. So now, I'm not going to go into the PC software to start it again. What I'm going to do, go on the keypad, like so, and do it from the keypad. So to menu 6, parameter 34. And there we've achieved the same thing. And there is our scope running. Now we're not seeing much current. So what I'm going to do is stop the scope. Go here, down the bottom, and change the scaling. I can also change it online. So if I hit delete and change it to 50, it changes in real time. If I go back to time base, and I'll dial that back a bit, we can actually see things happening nicely in real time. Like so, if I stop it, it clears the capture. That restarts it again like that. So we'll go back to channels. Yellow is motor RPM over there. Red is voltage, and green is the current. So you can see the current spikes when it accelerates, but the little current during steady state. Steady state is a little unstable because we've running an unloaded motor. Now we're running it without any feedback device. This is armature feedback. So there's a little bit of overshoot there as well. But overall I'm pretty happy with how this drive is running. So I'm going to stop it again, like so. And that's going to conclude it. I'm happy with this. That is how I test the DC drive. Pre-inspection or pre-repair and post-repair. These are the checks we do. This is my day job, stuff that I'm involved with. Power electronics, it's interesting stuff. So I hope you enjoyed this quick little video about working with a variable speed drive, in this case a thyristor drive and a DC brush motor. Take care folks, ladies and gentlemen, and we'll be seeing you sometime soon for more stuff. Cheers.